Now the first thing we're going to talk about today is function composition. Function composition is another way of combining functions. Now we're used to adding, subtracting, multiplying, and dividing, but now we have to compose them. So first we'll see two functions. F of x is 3x plus 5, and g of x equals 2x plus 7. Alright, now of course we can add them, subtract them, multiply them, but now composition says this: f of g of x. Okay, so initially what we did in the previous sections, we would plug in a specific number. Alright, so just say we had f of 4, we would plug in a 4 for x. Or if we had f of 8, we would plug in an 8 for x. But now we have f of g of x, which means we plug in the entire function. So this is what we have. We have f of g of x. Our first letter is f. Alright, so that means we're going to start with our f function. So we're going to write 3. But instead of x, we put our entire g of x function in. I'm going to write it in a different color. Alright, so that is 3. Then times 2x plus 7 plus 5. I just wrote it in a different color so it'll stand out a little. Hopefully the color will show up. Alright, so now this we distribute 6x plus 21 plus 5. And when we work with our like terms, that's going to be 6x plus 26. Alright, so that's 6x plus 26. That's how we work f of g. Okay, so now we can come back. We'll do a few examples. We can work this exact same function, but now we could switch it and say that g of f of x. So now we start with the g function, since that's our first letter, and we replace the x with the f function. So we start, that's 2. Instead of plugging in a number for x the way we did in the past, we plug in this entire f function. 3x plus 5 plus 7. Okay, so now we distribute once again. That is 6x plus 10 plus 7, which in turn gives us 6x plus 17. Now, the first thing that you notice is when you multiply, it's commutative. And when you add, it's commutative, which means like 3 plus 5 is the same thing as 5 plus 3. Both of them are 15. 4 times 7 is 28, and 7 times 4 is 28. So commutativity holds when you're talking about addition and multiplication. But when you're doing composition, it does not hold, which means you will not get the same answer. F of x and f of g of x, I'm sorry, and g of f of x will not necessarily give you the same answer. Let's look at another example. Okay, I'm going to make this it doesn't want to erase. at the smart board. Alright. So just say f of x is equal to 4x plus 5, and g of x is equal to 3x minus 8. So we've got 4x plus 5 and 3x minus 8. Alright, so now, the very first thing I want us to do, let's try f of g of x. So we start with the 4, and everywhere we see an x, we plug in 3x minus 8. Plus 5, let me get out of the way. So instead of 4x plus 5, we write 4 times 3x minus 8 plus 5. Let's distribute 12x minus 32. 4 times negative 8 is negative 32 plus 5. Like terms, we go through our rules, and that gives us 12x minus 27. Okay. And that gives us 12x minus 27. Okay, and then by the same token, we can come back and we can switch that over to g of f of x. Okay, once we use our g of f of x, we start with 3. Start with 3, and in lieu of x, we need to write 4x plus 5. Like I said, I'm putting it in a different color. Hopefully it stands out. Minus 8. So instead of 3x minus 8, it's 3. And we replace it with the entire other function. See, this used to be just a single number. Okay, that is 12x plus 15 minus 8, which gives us 12x plus 7. And as we can see earlier, it doesn't have the exact same number as it doesn't have the exact same answer as your first problem when we did f of g of x.